Hi, so we'll speak about the basal ganglia and the circuits first. So, what is the basal ganglia? Basal ganglia is the important lower nuclei. They are subcortical nuclei. Okay, so they are subcortical, very important, and even though they do have a very important function in the voluntary movement, there's a lot of thing about the basal ganglia that yet remains ununderstood. That's not that clear. All right, so let's just look at the different parts of the basal ganglia. So the main nuclei that we need to know about are the ones that will be highlighted. First is a caudate, right? So the caudate nucleus, obviously. Then the putamen, the globus pallidus, the subthalamic, and the mammillary body. Okay. Obviously, thalamus is also a very important part of the basal ganglia. Now, once we've understood these, let's just place them where exactly they are. According to the picture, obviously, we can see that here we've got the caudate nucleus, which is very close to the lateral ventricle, so somewhat in this vicinity. Then we've got the putamen. We've got the globus pallidus externus. Then we've got the globus pallidus internus. We've got the thalamus. We've got the subthalamus. We've got the substantia nigra. And this is how, in my head, and I just placed it something like this, that putamen is something that is very close to globus pallidus, and caudate nucleus is not something that we do not really want to associate with. Now, there are two things that we should know about them. Is that there is something called a striatum. Striatum is equal to putamen plus caudate nucleus. So the putamen and the caudate nucleus is equal to striatum. All right. And lentiform nucleus is the putamen and the globus pallidus, externus, internus, both. The reason why the anatomy of these structures is not as important as the pathways. So let's look at the pathway. Now, the way I remember is that there are two pathways. There is the direct and the indirect, and there is a rule that I follow. First is the positive, then you have a double negative. All right, and in the end, the last pathway is again positive. All right, that this is the direct, this is the indirect. So the rule is first there's a positive stimuli, there's a negative stimuli, and then there's a positive stimuli. Now we just need to place it at the right spots. All right, so first there's a positive stimuli. The positive is from the cortex to the putamen in the direct pathway, and so in the indirect pathway as well. As we can see, the positive for direct and indirect is the same. Then there's the second negative pathway, all right, which starts from the putamen and goes to the globus pallidus internus when it's the direct pathway, and that is why it's direct, because it's going directly to the globus pallidus internus. All right, but in the indirect, obviously, you need to know that it does not go directly into globus pallidus internus. It first gets into the globus pallidus externus. All right, so it goes to the globus pallidus externus, and again, as the rule, it has to be negative. All right, now, as the rule suggests, there is going to be one more negative in the direct pathway. Correct, there's going to be one more negative in the direct pathway, which is going to be from the globus pallidus internus to the thalamus. So that's another negative, and then the positive from the thalamus to the cortex. All right, so that's the direct. And the indirect pathway is something like, first you have the positive from the cortex to the thalamus, from the cortex to the putamen, correct? Then you have another negative from the putamen to the globus pallidus externus, and that's why it's indirect. from globus pallidus externus to internus, you will have, from globus pallidus externus to the subthalamic nuclei, sorry, you will have another negative. As I've told you, you need to have a negative. The rule is positive, negative, negative, and in the end, again, it has to be a positive. All right. So now there is one extra step. All right. Actually, there are two extra steps. There is another positive circuit, which is from the subthalamic nuclei to the globus pallidus internus, and from there we have another negative that goes to the thalamus, and from thalamus again we have a positive. Okay, it is a little confusing, so I guess we'll have to draw a circuit for ourselves as well. All right, so let's have a look. Okay, again I'll get into the structures. Here we have the caudate. So let's say this is the ventricle, this is your caudate. All right, this is your caudate, as we'd seen in the picture as well. The lateral ventricle, the caudate. Then we have the putamen, we have the globus pallidus, we have the subthalamus, we have the thalamus, and that is about it. Well, this is the anatomical picture somewhat. To make it more physiological, let's draw this as the cortex. Okay, this is the cortex. From the so we'll use two color schemes. All right, red is going to be stimulatory and blue is going to be inhibitory. All right, sounds good. So from the cortex, obviously we need to know that there's going to be a circuit in the putamen. All right, so this is going to be your putamen. Then I want you to understand that there's going to be a globus pallidus externus and an internus. Then there's also going to be a subthalamus, there's going to be a thalamus, and then again back to the cortex. So far so good. All right, so first we are looking at the direct pathway, and note that this is positive stimulatory and blue is negative inhibitory. All right, so far so good. From the cortex, as I've said, for the direct pathway, the scheme is positive, negative, negative, positive. Right? If I have to be more perfect, this is negative, negative. All right. So first we have a positive. All right. Now, according to the rule, it's a direct pathway, so we do not want to look at globus pallidus externus. We directly want to jump and go into globus pallidus internus. All right, negative. Then from globus pallidus internus, we want to go back to the we need to go back into the thalamus as a negative, and again from the thalamus we need to have a positive. This is your direct pathway. All right. In any case, the rule is followed: positive, negative, negative, positive. Now the thing is, let's say your body or your mind decides to start an action. You're going to have a positive stimulatory impulse, and here you'll have a lot of stimulatory neurotransmitters released, and these neurotransmitters are going to stimulate this first blue color neuron, which is from the putamen, the globus pallidus internus, and is going to cause the release of inhibitory neurons out here. So eventually this particular nerve fiber that is from the globus pallidus internus to the thalamus is going to be inhibited. It's going to be inhibited. That means there's going to be no release of neurotransmitters at the thalamic level, which means that the thalamic neurons from the thalamus to the cortex is going to be uninhibited, as a result of which your motor action is going to be carried and you will have a strong motor action. All right, you'll have it's a excitatory pathway, and therefore the direct pathway is actually your excitatory pathway. Therefore, the direct pathway is your excitatory. So the pathway has been explained. Why the pathway is excitatory is also explained. All right, now let's look at indirect. All right, now indirect, we are going to make the same boxes. Here we have your cortex, then we have the putamen, we have the globus pallidus externus, GPI internus, globus pallidus internus, subthalamus, thalamus, and back to the cortex. Now, the rule for indirect is that it's going to be a positive, negative, negative. In the end, you want a positive again. All right. It's going to be a positive, negative, negative. You will have a positive again, and you'll have a negative, and then again a positive. Okay. Let's not remember the indirect just by the positive negative rule, because direct is pretty simple. It's a positive, double, negative, positive. It's as easy as it gets. But in indirect, you need to use a little bit of brains, or you could just learn it like this, that there is going to be a positive, a double negative, then a positive, and then again a negative and a positive. However, obviously, you could also remember it in a more logical fashion, is that obviously till here everything is going to be the same, that there is going to be a positive. Okay, there's going to be release of hormones. All right, and then you're going to have a negative that is out here till globus pallidus externus, right? Till globus pallidus externus. From globus pallidus externus, you have, because it's an indirect pathway, you have something as a globus pallidus to subthalamus. All right. From subthalamus, you have a positive, okay, to the globus pallidus. From the globus pallidus, you have a negative going to the thalamus. So, another way that you can remember is that from the globus pallidus, let it be externus or internus, obviously, from the internus to the thalamus, in the end, you need to have a negative. And from the thalamus back to the cortex, you will have a positive. All right. So there are certain circuits that remain the same, and that I'm going to mark with green. First is the circuit that is from cortex to the pallidus is going to be the same. Second circuit that is going to be the exact same is the globus pallidus to the thalamus. And third circuit that's going to be the same is thalamus to the cortex. As simple as that. All right. Now the concept behind this, okay? Let's say the first neurons, that's the corticopallidal neuron, is stimulating the palato-globus pallidus external inhibitory fibers, as a result of which these fibers are inhibited, all right? And the substantia and the subthalamus can overfire. When the subthalamic fibers overfire, the globus pallidus internus are stimulated, and they are definitely going to inhibit the thalamic or the thalamocortical neurons. And the thalamus is actually the ventroanterior and the ventrolateral nuclei of the thalamus that are going to be inhibitory. So they'll be inhibited, and again the impulse to the cortex is inhibited. So indirect is your inhibitory pathway. All right. So that's why we saw the direct and the indirect. What fibers, what connections remain constant is also pretty much clear. The only thing that now matters is the dopaminergic. The dopaminergic pathway, or the one that comes from the substantia nigra, all right, from the substantia nigra, where exactly is it actually even going to stimulate? Well, you need to know that the substantia nigra has neurons coming from substantia nigra, the dopaminergic neurons. They have two receptors. They have a D1 receptor and they have a D2 receptor. So when we are looking at your direct, this is your substantia nigra, it has a D1 receptor. The direct pathway has the D1 receptor. So what happens is that when dopamine goes and stimulates, all right, it stimulates the D1. What it does is that the D1 receptors are stimulatory, all right, but the D2 receptors themselves are inhibitory. So I want you to remember one thing, that the D1 receptors are in the direct pathway, they are stimulatory, but the D2 receptors are inhibitory and they are in the indirect pathway. Now you need to remember one thing, that the substantia nigra has a nuclei that wants you to have a profound and very active action. It is more of an excitatory nuclei that's going to have an excitatory effect on this entire circuits. So if obviously if I'm saying is that the substantia nigra in the